So we drew these graphs connecting these stations, right? So we drew edges if you can go by train from one station to another station. Directly.
Which means the train departs from this station at some point in time
and goes to that
arrives
station.
at that station sometime later. Yeah.
But now, supposing I want to know something the other way around.
What is the other way around?
So I am on one train and I want to know if I can continue my journey on another train.
Connecting train, what do you mean?
So I want to know if there is a station where I can get off and switch over to another train. Supposing it is my desire to get onto a particular train and I am on some train. So is there some way I can get to a place where I can
connect to the other train,
catch that train?
Right? So you are trying to now draw, from what I understand, you are trying to draw
connections between trains. Yes.
So the nodes are trains now.
Yeah. So we want. Yeah. So the nodes are trains.
Earlier the nodes were stations and the trains were the edges.
Yeah. And
now you want to make the node the train.
And the edge will be representing a common station.
Common station is an
where
edge.
I can get off.
Where I can transit.
Yeah. Transfer from this station to that.
So which means this train and that train should be
crossing at that thing. Yeah.
Presumably you get off at that and the other train should come later.
Yes.
Huh? No,
of course. Of course.
You came earlier. Of course you can wait.
Wait till next week.
No, that doesn't make sense. Yeah. So presumably you get off at the station, you wait for a few hours, maybe 1 hour, I don't know, something like that. Have a cup of chai or something.
Yeah.
Something to eat.
And
then the other train comes, you get in and you go. Something like that. Huh?
Yeah.
Okay. How do you do that? I mean,
So we would have to, I guess, again, for like we said earlier, I mean, the way we looked at
trains.
Where we look at stations was we would check if there was a station and a train in common between the two. So each station had a list of trains.
You have to take 2 trains.
Yeah. Now we have to take 2 trains and see if they have a station in common.
Wow.
And then of course we have to worry about the date and the time and all that. But first let's just check this. If we are not worried about the time that it takes to make this transfer, is there at least a station where I can switch from this train to that train?
So you draw, okay, so we pick some trains and work on it?
Yeah, so we have some trains. Let's look at these trains, for example. These might be a good starting point. So we have.
These are
so
going from somewhere to somewhere.
So some of them we had seen when we had already looked. Because we had seen trains from Secunderabad. So this is Secunderabad to Delhi and reverse. This is from Pune to Kolkata and the reverse. This is from Mumbai to Calcutta and then Calcutta to Mumbai. And then there is a train which goes to Nagpur, which is also a station which we
Bhusawal is all right.
Yeah, and finally we had looked at Vijayawada, so that is a train which connects Secunderabad, Vijayawada and
Vishakhapatnam. So fine, so it's based on what we saw earlier.
Yeah, so some of these we have seen before. So now let's see what we can do with these trains, right?
So what do? Do you draw every train here? Or one is the opposite of the other, right? If you draw, there are 10.
So maybe we can just do the 1/2 of everything and then it will hopefully
turn out the same, huh? We'll see. Let's try it out.
Yeah.
So you want to draw a node for 02285.
Yeah. So we're just drawing a graph. At this point, we're not doing a table, right?
Okay.
We're just doing a graph. So we have
02285. That's a node now.
Yeah.
It's not an edge.
It's a node. And now we want to know,
Let's
for
say
instance,
you want to go to 12221.
Okay. So you want to know whether this is connected to 12221 or not.
So to say whether 02285 is connected to 1221, there has to be a common station.
Yeah. So Secunderabad, so Balar Shah, Nagpur. And
Nagpur is there.
And we see Nagpur is here and we see Nagpur is there.
Yeah.
So we can draw an edge.
So how would you go? I mean, from Secunderabad, so you are taking this train, you are on this train.
Yeah.
Secunderabad, you get off at Nagpur at 2100.
Yeah,
9 o'clock.
9 p.m. And at 4 a.m.
Oh.
But it may not be the same day. We have not checked the days. That's a problem. But at least if it were every day, then you would have a few hours wait and then you would do it.
Okay.
Right? So you can draw this edge now. Right? And maybe you could label it as Nagpur.
You're labeling the edge with the station name now.
Yeah. So earlier we had taken because earlier we had taken the stations and labeled the edge with the connecting train. And now we are talking about like a transfer station.
This is interesting, right? Because I mean, you can do it both ways. I mean, this seems, so the graph is a very powerful structure. Huh?
Yeah. So now we could
All
do the
kinds of
same
things
thing.
you
For
can try.
instance, we can look
Okay.
at
So
this and this, for example. So let's look at
02285 and 12261.
yeah. So we have 12261, and again you see that Nagpur is there.
Oh.
Right? So Nagpur seems to be a common station.
So you get off at Nagpur at 9:06 and then catch the 12261 at 4:10 again.
Yeah.
Same thing.
So these two trains happen to pass through Nagpur at the same time. I think maybe on different days of the week, but so again I can write this and I can write Nagpur here.
Okay.
What about 12289? Again Nagpur. So this is also connected.
Via Nagpur.
So again via Nagpur.
This time you catch it at 7:20.
Yeah.
This guy is there every day. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So you will at least
Yeah, that at least
nothing you get off from 02285 at Nagpur. You get up when 9 o'clock. Next morning 7:20 you can catch. For sure you will get this train.
And then the last one is
Depends on where you are going, but
2203, and that is connected.
that guy is arriving at Nagpur. So if you want to go from Nagpur out, you have to take this train.
Okay. So we have to go to 12290. Shall we change this to 90 here?
Yeah.
Because we are not going to go anywhere. Right? So I will write this as 12290. Okay. And this is a train which is starting at Secunderabad. So those trains end at Secunderabad respectively.
Here is one starting at Secunderabad.
So now how do we connect this? Well, we can connect from there to here.
Okay.
Right? So we can say that if we are in 22203, then we could get off.
Visakhapatnam, you can go to Secunderabad, and from Secunderabad you can go to.
Yeah.
So you arrive at 6:15 and 1:10. You wait in Secunderabad to catch the 1:10 train.
Yeah.
And
Assuming
go
the
to
days
Delhi.
work out, which may or may not happen, but
Then you go to Delhi or whatever it is, right?
yeah. So this is one set of.
Yeah, Thursday, for example, you can do it.
Yeah.
Sunday also you can do it.
Then, for instance, we could look at some other pairs. So,
Take these when we connected that to these, but somewhere in the middle we should try.
yeah, sure.
How about doing 1221 with 12261? 21 and 61, these two.
Okay, 21 and 61. So, of course, they both pass through Nagpur, which is not. So, in some sense, they are connected via Nagpur. So, it depends on where in both directions you can go.
You know Bhusawal also?
Bhusawal, Nagpur. Yeah, so we could actually put more than one station on that edge if we want. Is that okay?
Yeah,
I guess so.
Or
So-
put more than one each.
So now it can
So
go both
Pune
ways, right? So you can come
In fact,
from
actually,
Pune to
Bhusawal.
you can come out Pune to Bhusawal and switch over. You can come from Mumbai to Bhusawal and switch over. So it's actually the edges in both directions,
Yeah,
right?
yeah.
Edges in both directions here. Even there were the edges in both directions. Secunderabad to Nagpur and you switch over, but then Pune to town then you switch over. So again, actually technically, should I just put both directions there or what
Think
should
so.
we do?
Yeah.
So maybe if they're both directions with Nagpur, I'll just draw one edge and put
Both sides,
two
yeah.
arrows rather than drawing too many lines. I'll draw it like this. And the same is true, I think, of this and this. No, this is only one direction, right? Because 1, 2, I can't come from here and switch over to that. I can only come because this is starting here and at Nagpur, this is because it's starting at Nagpur. So it's only one direction. But 1, 2, 2, 6, 1 and 2, 1 have this feature that they are both connected in both directions to this. Whereas this train and this train have this thing that they go to Secunderabad. So 22203 goes to Secunderabad and then you switch over, but you can't go back the other way.
Correct.
Fine. So now we are saying that between these two you could switch over at Bhusawal or at Nagpur.
Yeah.
Even at Bilaspur or Tatanagar or Calcutta.
But you should do the first one, I think.
Yeah. So let's do Bhusawal.
Pune to Bhusawal, and then Bhusawal.
Yeah. So the earliest point in some sense that you could switch over and you can do it in either direction between these two.
Of course, you can go from Pune to Mumbai directly. You don't have to go to Bhusawal. But anyway, if you wanted to, with these two, with this example.
Yeah, you could go there and then. Well, technically you can only go forward. If you want to go backwards, you will have to go
Of course,
to this.
you want to go to Igatpuri, for example.
Yeah,
then you the way, right?
No, but you will have to come to this train to go to Igatpuri, right? Because this train doesn't go to Igatpuri. It's coming from Igatpuri.
Yeah, you take this.
So that would be a different. So you would have to look at. So So you have to put say 122262 and then connect that also in both directions. But then you have to look at the list of stations to know what this extension looks like.
So if you, so presumably if you have done the stringing, right?
Yeah.
If you have connected one train to another train, it says basically that I am traveling on this train. I go on till I reach the station.
I reach the station, then I
At that
switch
station I switch over
and then I can continue.
But then I can try to make a kind of a list of stations.
Correct.
Which is from this train I take the list of stations up to the switchover point.
Absolutely.
And from that I take the list of stations in the other train.
Correct. So for instance, we could start this, right? We can start from here.
Let's start like, let's do that.
So we can do,
I want to do
Vishakhapatnam,
then I can do Vijayawada, then Secunderabad,
then I do Secunderabad, then I switch over to come here,
then Belharsha, then Nagpur, then Bhopal.
No, but I'm going to switch
Nagpur,
over
again
Nagpur
switch
to this train.
So
then I do Bilaspur.
Then I do Bilaspur.
And then I do Tata Nagar, and then I do Calcutta. Right? So I can go by a very roundabout way from Vishakhapatnam all the way around and go to Calcutta instead of just going up the coast.
Which might make sense if you want to visit a few other cities, right?
Yeah. And on the other hand, if I switched over to the other train, 122261, also the same thing would happen, right? But we saw that this is also connected to 122262 via, so for example, this would be connected to 122262 via Nagpur, right? So there is also a connection from here to here. Via Nagpur. So if I followed that connection, I would come up to Nagpur and then I would switch over to 122262 and then I could do Bhusawal, Igatpuri,
go to Mumbai
and Mumbai instead. Right? So I can go from Vishakhapatnam to Mumbai.
So you know, for example, I am in Vishakhapatnam. I want to go to Mumbai and Calcutta.
Yeah.
What I could do is I could go from Vishakhapatnam to go to Vijayawada,
Secunderabad,
Belharsha, Nagpur, get off at Nagpur, book a hotel, stay there, right? Go to Bhusawal, Igatpuri, Mumbai, visit Mumbai, enjoy the Mumbai Gateway of India, whatever it is, all those things. Come back Igatpuri, Bhusawal, Nagpur, go back to my hotel, stay there.
And then go the other way.
Again, Bilaspur, Tata Nagar, Kolkata. See Kolkata.
And then come back.
See cricket match in Eden Garden Sunday. Tata Nagar, Bilaspur, Nagpur. Stay in the hotel again.
And then maybe trace my route.
Secunderabad. I can do that.
Yes.
So this is useful. I mean, this kind of stringing.
Correct. So you have basically these lists, so they're interesting, right? So you have this list which comes from one train, and then it will overlap at that. So you have this overlap. So this goes up to Nagpur, and then Nagpur. So you have these three lists. So you have this one list, then you have this other list, and then you have this third list.
Right? And there's fourth on the bottom.
And then at the bottom you have another fourth list, which also starts at Nagpur and goes up to there.
So it's basically the segments of stations.
So you have this, you have a list, and then you have another list which overlaps at the changing point, and then you have another list which overlaps at the changing point, and by this you stringing together
one long word, right? Long word by taking.
So some this word building. My word ends in E. You must start a word with E.
I know.
Then if you think of all those words, so I stop at a station. Now you must get on at that station and continue
like
the
that
journey, right? So so you could actually play this game, right? So you could see how long you could go without getting stuck, right?
So is there a way of finding out whether I can visit, let's say in 2 days, I start today morning, early morning, and I am willing to go up till tomorrow night. What's the maximum number of stations I can visit? Maximum, like this you got. But if you don't know whether it's the same day or not. But I want to do this in a limited amount of time. I have only 2 days. I want to visit as many stations as possible. Via train, I will not get on. Only some places I may get on.
So you should first of all, I guess, start your journey as close to midnight as possible.
Okay.
Right. So you must look at stations where there are departures close to midnight, soon after midnight.
Okay.
Then you look at those trains which are leaving at that time from these stations. So let's pick any one station. You list out all the stations.
Yes, they will pick Delhi.
So let's pick Delhi.
Okay.
So you start looking at the trains which leave soon after midnight at Delhi.
Okay.
So you take one train, look
Where
at it,
it's going, keep going,
and see how far you can go in one day.
That may not have too many stations, that's the only problem.
Yeah. So then we might also want to switch over to smaller trains because they stop at more stations. So I think you will have to check every one of these possibilities, right? Either you have to go straight through to the end of that.
It's better to do trains. I mean, you take a train and see which train has the largest number of stations in one day.
Okay, and then you can say where to
in
get
fact,
on.
Actually, you should not even just do one day. You should do segments of the day. Let's say the morning, afternoon, evening. Divide into some segments.
Okay.
Then if I have a way of stringing together, like we did, stringing.
Yeah. So
I take in the morning, let us say there is one train which has got large number of stations. In the afternoon, there is another train which is doing large number of stations.
So can I get from this train to that train? That this graph will tell us, right?
Something like
Is there a way to transfer from this train to that train?
And then string together and something like that. Some such thing.
Yeah. So that's a possibility. Yes. So one could use this kind of information to first look at these kind of dense segments where the train stops at a lot of places.
Lot of stations.
Within a day, within a half a day say, and then put these two segments from two different trains together to get a long segment of lot of stops. It's possible, we could do that.
Okay. Don't right now, it's going to take too long.
But you can do some kind of
processing.
Yeah, so you can first process all the trains, as you said, look for those which have, I mean, obviously you would not pick up these trains which have only 2-3 stops.
Stations.
Yeah, so you would look for trains which have more stops and then try to string them together to form these segments.
I have another question, right? I mean, it occurred to me when we were doing this stringing of trains and things like that. Often we saw these segments, right? Where one train is coming behind the other train.
Yes.
So one train goes, then the other train comes, waiting for this train to have crossed, then it will cross, right? Like that. They come one behind the other in those segments. Now, if the first train is delayed,
then the second train is very likely to get delayed. Yeah.
In fact, there is a third train coming behind, that also is delayed. So delaying, one train gets delayed, then it creates delay
for a number
of trains. So if I know one train is delayed, can I find out which other trains will get delayed by this? How much delay will be there also? So I can tell people now. So for example, I know this train is delayed. If I can predict, that not only is this train delayed, this train is delayed means down the road, this train in various stations it's going to come late. But because it's coming late in those stations, other trains which are going to come behind it in those stations will also delay. So I can inform people, no? I can send them an SMS or something telling them that your train is going to be delayed. No, so they don't waste their time. No, so if there is a way to predict, that will be very nice.
Yeah.
How do I do that?
So again, you could draw a similar. I would say the following: you take a train, and you see if there is a station. First of all, there should be a sequence of stations, maybe that they are following the same route.
That we saw here.
Yeah, like here, for instance, like this Nagpur, Bilaspur, Tatanagar, Nagpur, Bilaspur, Tatanagar, Kolkata. And then you see
one station is okay, right? Even if one station they are overlapping, they are likely to be overlapping more than one. That's what I've seen. But even if there are one station overlapping and one guy is coming just slightly behind the other guy in that station. So the station tells you actually. If you look at the station, it tells you which trains. It
tells you the train which train is coming next. Right. So
let's take one example of a station.
Let's take Nagpur, for example. Nagpur will have these are trains.
We saw Nagpur has a lot of things.
Yeah.
Nagpur, Bisawal and all that, right?
Yeah.
Okay. Which way before? Delhi, Nagpur. Okay.
Yeah. So what you're saying is that, for instance, if this 12:221 is delayed,
12:221 is delayed,
then this thing will also possibly.
Let's say it's delayed by 1 hour, right? 4:15. It's supposed to arrive at 4:10. It's delayed by 1 hour, so it arrives at 5:10, and it waits for 5 minutes. It leaves at 5:15. So this guy can come. Actually, in principle, it can come at 5:15. So no delay. But instead of being delayed by 1 hour, it's delayed by It's 2 hours.
Hmm.
Okay, one possibility is that this fellow arrives and goes away and then that guy comes later. But usually that never happens because they are coming one way or the other. I don't know. You have to see that, okay?
Yeah.
But assume that, for example, that's not the case, that this guy is going to wait.
Yeah.
Then this fellow comes at 4:10, instead of 4:10 he comes at 6:10.
Then this train is
And
delayed.
he delays at 6:15.
And this train
Then
is
only
at,
this guy can come.
so 1 hour delay come.
1 hour delay.
So 2 hour delay there means translates to 1 hour.
1 hour delay for 2286.
Hmm.
Right? So this guy is now 6:15, he leaves at 6:20. This guy also 6:15, 6:20. Right?
Hmm.
Different platform, I guess, presumably. I don't know what it is. Huh? Or no, different days, I don't know, something.
Different days, yeah.
Then this guy is at 7:20, so no problem.
Hmm.
So the delay only has propagated to this train, it has not propagated to this train.
Yes.
But because this guy is delayed to 6:20 now, 2286, even this guy is delayed. This guy is delayed to 2286. You have to see where all 2286 is going.
Yes. Yeah. So for instance, you see this is we have 2286 here, for example. Then you have to go and see whether after this in Balar there will be some other train perhaps which gets.
Balar is a small station.
Yeah, or Secunderabad.
What happened in Balar? Let's take Balar. Okay. So Balar we got. So he got delayed by 1 hour, right? So Balar 2286
arrived at 8:10.
Instead of arriving at 8:10, now he came
at 9:10.
Unless he made up the time. Sometimes he make up the time. But assume that 1 hour he didn't make up. So he came at 9:10. So because he came at 9:10 and departed at 9:15, it did not have any impact on the other trains.
Yes.
So no problem with Balar. Okay. But what is the next one?
Secunderabad.
Okay. Secunderabad. So what is the train? 2286.
2286.
2286. 2286 supposed to arrive at 2, it came at 3.
Again, no problem.
No problem. So we can therefore, like this, one can propagate, I presume, the delay, right?
Yeah. So at that station, first you look at within the station, if I have a certain delay, how many trains are arriving within that delay, and therefore what is the amount, minimum they will get pushed by this delay. Then you can go to the next station and those trains and say now this train is going to reach those stations, assuming that the delay is not made up. You can say that this will therefore reach 1 hour later at the next station. And then again do the same thing. Propagate it and see how many other trains at that station will get pushed.
Yeah.
And then look at their corresponding next station and so on until we reach a situation in a station where it says, okay, this next train is sufficiently far away that it is not affected by this. So this would kind of
propagate the delay.
Yeah, so you have this kind of influence. So you have one delay here which influences trains at this station, that influences trains at neighboring stations, that influences other trains, which influences more neighboring stations, and then hopefully this eventually peters out. It becomes because there are gaps between trains which are longer than the delays, then you get. But yeah, so this is
interesting. So if you think about it, they have made a graph, right? You made a graph of trains. Actually, it's trains and stations. Either trains and nodes, stations are edges, stations are nodes. Trains are edges, I don't know, whatever it is. Or it could be just what we saw in the dictionary thing. You have a dictionary of train which link to list of stations.
Yeah.
You have a dictionary of stations which link to list of trains. Whichever way, something. Okay, some way of representing this. Then what you are doing basically is that this graph, you are actually propagating the delay, right?
Yes, pushing it through
the graph. Yes. It's like water.
Yeah, the pipes. Yeah.
You put it goes through the pipes like that.
Yeah, and
it's
then
going through the pipes or the edges of the graph. You put the water on the node, it went drying, it went through the edges, and then after some time
it dries up.
There's no more water going anywhere. It stops. So the delay stopped.
Yeah.
Right.
Right. So that's something else that you could do. Yeah. Correct.
So this graph is a very powerful thing. I mean, you can do a lot of things with it. Looks like you can use it for calculating distance. We saw calculating time. We saw
correct.
Doing this stringing of stations together and doing something with it. And right now we saw basically also delay propagation, which is useful, right? Because
definitely you want to know the impact.
We need to know the impact.
Yeah.